morning, myself Dr.C.SURESH, Assistant Professor, Computer Science and Engineering Department. Now I am going to take class about Computer Network, Unit 1. Unit 1 is about Introduction. The objectives of the Unit 1 lesson 1 is to understand the protocol layer and physical layer communication. What are the layers present in networks and what are the physical level communication, how it takes place. Next, outcome. First outcome is to understand the basic layers and its functions in computer networks. Second outcome is to evaluate the performance of a network. Third one is understand the basics of how data flow from one node to another. What is node? Node is capable of sending and receiving the message. We say it is nodes. The outline of the unit 1 is first one basics of communication, second one basics of networks, third one network models and types, fourth one is protocol layer, and last one is OSI network model. These are the outline of the unit 1. First one going to see about basics of communication. First, data communication. What is data communication? Data communication is defined as the exchange of data between two devices via some of the transmission medium. Some of the transmission medium means wired medium or wireless medium. Within these two medium, the data communication can take place. Having some three categories of data communication: delivery, accuracy, and timeliness. Delivery, it will define deliver to the proper destination. The second category of data communication is accuracy. What is accuracy? What the sender will send, the same will receive by the destination. It's called accuracy. Third one is timeliness. Timeliness means we send the message means it will reach in the correct time. The late message does not have value. So these are the components of data communication. In data communication, having 5 different types of components. First one is message, second one is sender, receiver, medium, protocol. This is the pictorial representation of components. First one is sender, second one is receiver. Sender will send the message to the receiver through some medium. This is wide medium, message having some information. Then what is protocol? Protocol is defined as the set of rules. Set of rules that govern data communication. That means sender and receiver must agree the common set of rules. These 5 are the data communication components. Next, data flow. The data will be flow which consists of 3 different types. How data can be transferred during the communication. How data can be transferred during the communication is called as data flow. The data flow can be carried out in 3 different ways. First one is simplex, half duplex, full duplex. What is simplex? Simplex, it means it is unidirectional communication. What is unidirectional? That is one-way communication only. That is example is FM radio or television. This is the example for unidirectional. Second, half duplex. Half duplex is it can be communicated two-way communication, but bidirectional different thing, not same thing. Example, walkie-talkie. We can communicate. Sender will send a message and receiver can also send, but not simultaneously. Between different time slots. That is half duplex. That is bidirectional only, but different time. Third one is full duplex. That is bidirectional at the same time. That is a mobile phone or telephone conversation. These are 3 different types of data flow in data communication: half duplex, simplex, half duplex, full duplex. So this is the data flow pictorial representation. This is simplex, the action of data. This is FM radio itself. This is the half duplex. They communicate both the sides but at different time slots. Third one is full duplex. It will be direction of data all the time, all the places. So next our concept of unit 1 is what are the basics of network. So this is the introduction. What is network? A network is a set of devices often referred to as nodes connected by communication links. What is node? A node can be computer, printer or any other devices capable of sending and receiving data generated by other nodes of the network. A connected collection of hardware and software that permits information exchange and resource sharing. What is information? The information which consists of what are information? Data, text, audio, video, images. These are all consist of information. So the network criteria, 2 different criteria. First one is 3 different criteria. First one is performance, reliability, security. Performance, how performance can be calculated by using networks? By using transmit time and response time. Second one is reliability, that is how the communication should be reliable. Third one is security. Any third party can be unauthorizedly access our internet. That is regarding security. These are the network criteria. What are the types of connections? In networks, it will having two different types of connections. One is point to point, second one is multi-point connection. In point to point connection, the link will be directly communicated to the station, sender and receiver. In multi-point connection, the link will be shared by using different stations. These two are the different types of connection. Next, going to topology. What is topology means in networks? It refers to the physical structure of network. What is topology? It refers to the physical structure of networks. Topology of network represents the geometric representation of links and linking devices. In topology, it consists of four different types of topologies: bus, star, ring, mesh. These four are the different types of topologies. First topology is bus. We are going to see what is bus topology. All the network nodes are connected with single network cable or link. Okay, all the network nodes, that is stations, are connected by using single network cable. Here we having one single cable. That single cable we using where the different stations are coming. Thus different stations are connecting. This is bus topology. In this topology having some merits and demerits. We see in the next slide. So advantages of bus topology is easy to install, require less hardware than other topology structure. Disadvantages, what is disadvantages? If any failure occurs, it stops the entire transmission. Difficult to reconnection and installation. It's one of the main drawbacks in bus topology. Next, going for star topology. Each device has a dedicated point-to-point link only to central control using called hub. In star topology, we are using the device called hub. By using the hub, the stations are connected directly with the hub by using dedicated point-to-point link. This also having some merits and demerits. So advantages is installation and reconfigure is easy. Robustness, if one link fails, only the link is affected. Okay, remaining, but compared previously we see bus topology. In that one station failure means remaining the cable remaining also having chance to affect. But this star topology, it will follow robustness. What is robustness? If one link fails only, the link is affected. Other station is not affected because the connection, all the stations are connected directly by the hub. So require less cable than you miss. Disadvantages is require mere cable compared to bus and ring topologies. And one more drawback is, if suppose the hub will be failure, means all the stations are stop communication. Next, third one is ring topology. In the topology also having dedicated point-to-point connection only with the two devices on either side. Having only cavity, the previous slide hub having more stations connected by using it. Here, dedicated point-to-point link, but two stations on either side of it. See, this is the example. By using the cables repeaters, the stations are connected by either side of it. Here two stations, the opposite two stations. Here one station, the opposite is directly connected to one station. This is the ring topology. Advantages is to add a device requires changing only two connections. Okay, the constraints and maximum ring length and the number of devices. If one device does not receive the signal within a specific period, it issues an alarm that alarms the network. This is one of the important advantages. Disadvantages is a break in the ring disables the entire network. If suppose in the ring topology, any breaks occur, it will be affect the entire topology, what are the stations connected in the network. Last topology we are going to see is mesh topology. What is mesh topology? Each device has a dedicated point-to-point link to every other devices. This is the combination of previous topologies. It's called mesh topology. Having dedicated point-to-point links. This is combination of ring also. So this is the pictorial represented. Here having 5 stations. All the stations are connected, dedicated connections. So advantages, if one link becomes unusable, it does not incapacitate the entire system. If one link becomes unusable, so it does not affect the entire station. All the connections are continuously going on. Privacy or security. So the privacy or security, when every message travels along a dedicated line, only the intended recipients only. That is proper, reach the message to the proper destination. See, these are best topologies having some disadvantages. The huge amount of cabling and the I/O ports required. Next one is installation and relay connections are different because it is a combination of many different topologies. Previously some more connections. The shear bulk of the wires accommodate more space than available. This cable space is more. Third opening of the introduction unit one is network model. The category into which a network fall is determined by its size, ownership, the distance it covers, and its physical architecture. Having three different types of network models. That is, first one is LAN, second one is MAN, third one is WAN. LAN, MAN, WAN. LAN, MAN, WAN. LAN is called local area network, MAN is called metropolitan, WAN is called wide area network. So this is the LAN introduction. LAN is usually privately owned and links the device in a single office building or campus. LANs have data rates in the 4 to 10 megabits. The second type of network is MAN, that is metropolitan network. A MAN is designed to extend over an entire city. Maybe a single network such as cable TV network. Maybe means of connecting a number of LANs into a larger network. A MAN can be owned by a private company, or it may be a service provided by a public company such as local network. Okay. Second, this is the pictorial representation of a MAN. It will be connected from different cities. So last one is wide. Wide provides long distance transmission of data, voice, image, and video information over large geographical areas. It may compromise a country, continent, or even the whole world. It will be connected to communication by using the WAN. Transmission rates are typically 2 Mbps, 34 Mbps, 45, 150, 650, or same time considerably more. A WAN that is only owned and used by a single computer is referred to as an enterprise network. So next, internet. What is internet? When two or more networks are connected, they become an internetwork or internet. Okay. What is internet? When two or more networks are connected, they become an internetwork or internet. This is the pictorial representation. It will be connected by using modem. There is modulation and demodulation. So this is the structure of national ISP, that is Internet Service Provider. The national ISP will be connected with region. Region will be given to the ISP. This is the national ISP. So the next going to start topic about protocol layering. What is a protocol layering? Already we said a protocol is a set of rules that govern data communication. It defines what it is communicated, how it is communicated, when it is communicated. Syntax. So having three protocols which having three rules. First one is syntax. What is syntax? It refers to the structure or format of the data. What is semantic? It refers to the meaning of each section of bits, how a particular pattern to be interpreted. Third one is timing. It refers to characteristics when data should be sent and how fast they can be sent. This is a timing. Next is some list of protocols in computer networks. First one is IP, Internet Protocol. Second one is ICMP, Internet Control Message Protocol. Third one is Transmission Control Protocol, that is TCP. Fourth one is UDP, that is User Data Graph Protocol. Fifth one is ARP, that is Address Substitution Protocol. Reverse Substitution Address Substitution Protocol. AODP, that is Attack On-Demand Distance Vector Routing Protocol. Last one is DSD, Distance Sequence. Timing Sequence Distance Vector. These are the protocols, important protocols followed in computer networks. The standards, it follows some standards. These are the following standard units. ITU, that is International Telecommunication Union. Second one is ISO, International Standard Organization. The third one is standard is ANSI, that is American National Standard Institute. Fourth one is IEEE, that is Institute of Electrical and Electronics Engineers. Last one is EA, Electronics Industry Association. Last one is Request for Command, that is Internet Standard, that is RFC. So next one is OSI model. That is, the OSI is the model. It was developed by ISO, that is the International Standard Organization. This is the model. OSI means model. OSI abbreviation is Open System Interconnection. This model was developed by ISO, International Standard Organization. ISO is the ISO is the organization. OSI is the model. So what is the role of OSI? The OSI model describes how data flows from one computer through a network to another computer. Okay, how data flow from one computer through a network. How data flow from one computer through a network to another computer. So the OSI model is not a protocol. OSI is a model. OSI model is not a protocol. It is a model for understanding and designing a network architecture. Understanding and designing a network architecture that is flexible and robust. So the layers of OSI model. The OSI which consists of 7 different types of layers. First one is physical layer. Second one is data link layer. Third one is network layer. Fourth one is transport. Fifth one is session layer. Sixth one is presentation. And last layer is application layer. These are all the 7 layers present in OSI model. So we see next one by one layers. First one is physical layer. What is physical layer? Physical layer is the bottom layer of OSI model. It is responsible for actual connection between the devices. The physical layer is responsible for movement of individual bits from one node to another. This is the physical layer introduction. So functions. What are the functions? The physical layer consists of 6 different types of functions. First one is manage physical connection. Second one is bitrate control. Third one is line configuration. Physical topology. Transmission medium. Multiplexing. These are all the functions of physical layer. Second layer is data link layer. What is data link layer? Data link layer is responsible for moving frames from one node to next. The previous layer is responsible for bits. This layer is responsible for moving frames from one node to next. So this is the diagram how the node will be traveling from one node to next. So functions is framing, physical addressing, flow control, error control. So network layer, it is responsible for source to destination delivery of packets. It is responsible for source to destination delivery of packets across multiple networks. Okay, it is responsible for source to destination delivery of packets. So these are the routing and logical addressing other functions. So the fourth layer is transport. Transport layer is responsible for source process to destination process. Source to destination delivery of entire message. Entire message delivery is the main responsible for the transport layer. So the main function is connection oriented transmission and connectionless transmission. Then segmentation, service oriented point addressing, error control, flow control. Then fifth layer is session. What is session? It is responsible for beginning, maintaining and ending the communication. It is responsible for beginning, maintaining and ending the communication between two devices, which is called session. So this is the diagram. The function is establishing, maintaining and ending a session, dialog control, synchronization. The sixth layer is presentation. What is presentation? It is the syntax and semantics of the information exchange between two systems. Syntax and semantics of the between two systems called presentation layer. The next function of presentation layer is data translation. That is, what is data translation? Encoding and decoding. Next, data encryption. What is the purpose of data encryption? For security and privacy purposes. Next one is data compression. Data compression reduces the number of bits contained in the information. Last layer is application layer. That is user supporting layer. Provides user interfaces and support. So this function is network virtual terminal, file transfer, access and management. Then last one is mail services. Next we are going to see about performance. What is performance? In networking is performance. How good it is? How good is it? This is called performance. That is performance by calculated using bandwidth, throughput, latency, that is delay, bandwidth, delay, jitter. So first one is bandwidth. One characteristic that measures network performance is bandwidth. Bandwidth in hertz is the frequency contained in the messages. Bandwidth in bits per second. The term bandwidth also considers number of bits per second that a channel or link can be transmitted. That is number of times taken. For example, one can say the bandwidth of the fast Ethernet network is maximum of 100 Mbps. That is performance. That is bandwidth. The last one is basically an increase in bandwidth in hertz means increased bandwidth per second also increases. Second, throughput. Throughput is a measure of how fast we can actually send data to a network. How fast actually we can send the data to a network is called throughput. Third one is latency. The latency or delay is how long it takes an entry message to completely arrive at the destination from the time first bit to the destination. That is how long time takes to travel from source to destination is called latency. Latency equal to propagation time plus transmission time plus queuing plus processing delay. These are combined are called latency. That is, next one is propagation delay. What is propagation? Propagation time equal to distance propagation time. What is transmission time? Transmission time means that is contains message size bandwidth. That is queuing time, that is waiting time. The time needed for each intermediate or end devices to hold the message before it can be processed. The queuing time is not a fixed factor, it may change. When there is a heavy traffic on the network, the queuing time can increase. Depends upon the heavy traffic on the network. Last one is jitter. What is jitter? That is different packets of data encounter different delays, and application using the data at the receiver side is time sensitive. Okay, this is our today's session and over. Remaining we see in the future classes. Thank you.